Hello, everyone. I am from the Japanese Business Alliance for Smart Energy Worldwide, or JASE-W, for short. Today, I would like to introduce to you the Waste to Energy Handbook that our organization has prepared. I will talk about the following points. I will start with an overview of waste to energy. I will introduce our organization. Then, I will touch on the background of the WTE Handbook, and why the WTE and the Handbook are needed. I will go on to give you an overview of the WTE Handbook, and I will talk about the concept of QWTEI, which stands for Quality of Waste to Energy Infrastructure. Finally, I will mention some important details of the WTE Handbook. I don't intend to overgeneralize, but I have often seen and heard about waste management in emerging or developing countries, that there is room for improvement in most countries, in the approaches for sound waste management and the actions needed to achieve it. To be more specific, it is necessary to grasp the current situation correctly, to have clear ideas as to the future direction, and to recognize the gap between the current situation and the future course. It is also necessary to find out where the problems are, in terms of the regulatory system and their administration, finance, technology, know-how and experience, and consensus with the local citizens. When those are done, you now start formulating the solutions, such as the establishment of laws and regulations, the introduction of financial schemes and new technologies, capacity building of the players involved, and the acquisition of knowledge. Ultimately, your country will enjoy many benefits, including sound waste management, increased public health, and a sustainably developed society. I should stress that introduction of WTE technology alone does not solve the waste management problem. Rather, it is one of the important tools for addressing the problem. In other words, WTE is an integral part of a waste management system, which is a major social infrastructure, and you make the decision to adopt an integrated WTE system, because there is indeed a need to build or improve the waste management system. The intermediate treatment process step in waste management, which is most relevant to WTE, is a multi-purpose process. During this process step, the collected waste is rendered less harmful, so as to improve public hygiene, and reduce the impact of the waste on the environment. At the same time, the volume of the waste is reduced so that the service life of the final disposal site, or landfill, can be extended. Power generation and other effective uses of energy from waste are of a secondary nature, in the overall system of waste management. Before going any further, allow me to briefly explain to you the organization I represent, namely, the Japanese Business Alliance for Smart Energy Worldwide, or simply JASE-W. The alliance has 44 corporate members from various industries of Japan. The Ministry of Economy, Trade, and Industry, the Ministry of Foreign Affairs, Japan Bank for International Cooperation, JICA, JETRO, and other government agencies or affiliates are represented as observers, and there are 21 association members, including ESCO providers and solar power operators. Currently, 6 working groups, each consisting of representatives from interested corporate members, are working to spread Japanese energy efficiency technologies overseas. JASE-W has published a booklet, Japanese Smart Energy Products and Technologies, which lists advanced technologies developed by JASE-W members. The technologies are classified into 9 categories: factory, industries, office building, residence, construction, transportation or logistics, power generation and distribution, renewable energy and storage, battery, energy solution service, and smart community. You can also access it in our JASE World's website, which is available in English, Chinese, Spanish, Portuguese, Russian, and Vietnamese. JASE-W has participated in various international environment energy-related exhibitions, such as WFES in UAE, ASEAN Clean Energy IGEM in Malaysia. These events are offering to introduce members efficient and environmentally friendly products and technologies. Now, let me come back to the topic of waste to energy. I will start with the background for the formulation of the WTE Handbook. Asia-Pacific Economic Cooperation, commonly known as APEC, took up the challenge of enhancing the quality of electric power infrastructure as an APEC initiative. The APEC initiative determined that 3E plus S, that is, energy security, economic efficiency, environmental protection, plus safety should be one of the basic frameworks for energy policy. With regard to quality waste to energy infrastructure, however, some additional elements need to be considered. The APEC Guidebook on Quality of Infrastructure Development and Investment, which was revised in 2018, recommends 5 elements that should ensure the quality of infrastructure in general. They are: 1. Alignment with development strategy, openness, transparency, and fiscal soundness. 2. Stability, safety, and resiliency. 3. Economic and financial soundness such as cost-effectiveness, including LCC and utilization of markets. 4. Social and environmental sustainability. And 5. Local high-quality development such as job creation, capacity building, and transfer of technologies. The WTE Handbook I am going to explain today is expected to be revised in the future, to reflect the shift from 3E plus S to the 5 elements. I'd like to now talk about the rationale for WTE and the Handbook. WTE is needed because rapid urbanization has brought about many environmental problems, and while the amount of waste keeps increasing, there are limits to the expansion of final disposal sites. And so, in order to ensure appropriate treatment and disposal of waste, new technologies become necessary. In light of these circumstances, our WTE Handbook lays out the minimum necessary checkpoints as to what should be done in the WTE bidding procedures, and how to evaluate a WTE bid according to evaluation criteria. This flowchart illustrates a typical bidding process for a WTE plant. The first step is pre-qualification, to select companies which are qualified to take part in the bid. Next, technical evaluation is conducted, and the results are communicated to the bidders. Then, the price proposals are opened, and the contractor is decided. Among those steps, our handbook places a special focus on pre-qualification. It is not an exaggeration to say that, if you do the PQ correctly, you are sure to enjoy at least a certain level of quality of the WTE plant. Now, I go into the handbook itself. First, the introductory part. The objectives of the handbook are twofold. One is to help readers understand how to place an order for WTE facilities. The other objective is to provide and share useful suggestions on the methodologies for ensuring WTE facilities of good quality. The targeted readers are officials of local or central governments. I should add that this handbook covers WTE facilities only, and does not include other related facilities or systems. It is very important to remember that there are significant differences between an ordinary power generation plant and a WTE plant. Waste management is not a service that local governments perform to earn revenue. Rather, the most important objective of waste management service is to ensure public hygiene. The main purpose of power plants is to generate electric power and sell it, while that of a WTE plant is to treat waste appropriately. Please take a look at these graphs. In the waste-to-energy service, the total cost is covered partly by the revenue from the sale of electricity through the feed-in tariff system and others, and the rest is shouldered by the municipality in the form of tipping fee. The waste has to be managed at the WTE plant by all means, and so, cost minimization should be pursued, rather than revenue increase. This slide gives an overview of the concept of quality waste-to-energy infrastructure. QWTEI is a waste management plant, an important part of basic urban infrastructure. Accordingly, it should serve to protect public hygiene constantly, and, as such, it must keep running stably. For this reason, we have included some components that are specifically important to QWTEI, in addition to the elements required for ordinary power plants. Making positive contribution to public health is the most important objective of waste-to-energy facilities, and power generation is a secondary objective. They must conform to all of the 5 major components, namely, public health, stable operation, environmental conservation, safety, and economic efficiency. In this handbook, these 5 major components are used to determine QWTEI. One of the major components, stable operation, is further divided into 3 QWTEI components, namely, initial performance, stability, and ability to smoothly stop and recover. Furthermore, 2 additional QWTEI components, namely, acceptance capability of waste characteristics fluctuation, and durability, have been added as important characteristics of the QWTEI, to help maintain public health. As a result, as you can see in the chart, the handbook defines QWTEI as an aggregate of the following 8 components. 1. Initial performance. 2. Stability. 3. Ability to smoothly stop and recover. 4. Acceptance capability of waste characteristics fluctuation. 5. Durability. 6. Environmental and social considerations. 7. Safety. And 8. LCC. The handbook consists of 3 parts. They are Introduction, Parts 1 through 3, and Appendixes. Part 1 defines QWTEI. Parts 2 and 3 describe factors that you should consider to ensure quality during the phases of feasibility study, planning and construction, and during the operation phase, respectively. We believe that the targeted readers of the handbook would be most interested in the practical information contained in Part 2. Well, then, let me explain the 8 components of QWTEI, one by one. First, initial performance is defined as the ability of the WTE infrastructure to commence operation as initially planned and scheduled. Effective ways to achieve the desired initial performance include sufficient market sounding before bidding, setting the minimum necessary performance and including it in the order specifications, organizing a scheme to fully evaluate the track record, method, and time schedule of the proposed construction work prior to bid opening, and performance check before final delivery. Stability is defined as the ability of the WTE plant to continue treating waste in a stable manner. Generally speaking, the performance of a WTE plant goes down gradually, with the passage of time from the start of operation. There are 3 important things you should consider in order to ensure stability. First, it is necessary to fully consider, during the planning and bid preparation stages, the range of waste types which would be brought into the WTE plant. Second, operations should be optimized through adequate maintenance planning and execution, including scheduled shutdown maintenance, continual training of operators and maintenance engineers, periodic check of equipment operating conditions, and performance evaluations based on actual performance data. Third, you need to take measures in accordance with the site location environment, to protect the infrastructure against strong wind, salty water and air, heavy snow, lightning, earthquakes, etc. You should plan on expecting the WTE infrastructure to demonstrate good performance for 20 to 30 years. The ability to stop smoothly is defined as the ability to prevent forced outages to the greatest possible extent, and to bring the plant to a safe halt without leaving damages to the equipment. The ability to recover is defined as the ability to recover promptly from a forced outage. In order to minimize the duration time of a forced outage, it is important to detect in advance the signs that appear in the operational data and the like. If continuation of appropriate waste treatment is threatened, the plant should be shut down immediately. To keep the forced outage period as short as possible, the infrastructure should have sufficient structural strength, and you should never operate it beyond the design structural strength or the safety factor. The acceptance capability of waste fluctuation is defined as the ability to determine the necessary functions and equipment of the plant, in order to respond to short-term and long-term fluctuations of waste characteristics. The ternary graph in the slide shows the moisture, combustible, and ash content of the waste. The green area represents the characteristics of waste that can be regarded as combustible, according to the World Bank guidelines. If your waste has lower calories than the waste in Japan or Europe, you will hope that the green zone, which represents the properties of the waste that you can incinerate without any auxiliary fuel, would be as big as possible. This can be made possible by Japanese technologies. Waste with high moisture content can be incinerated with no additional fuel. This is very important in countries where kitchen waste occupies a large portion in municipal waste. Durability is defined as the ability to design the functions and equipment of the plant for maximum service life. Because a WTE plant is typically operated for 20 to 25 years, the bidding contractor should be capable of carrying out repairs, according to a good maintenance and repair strategy. Environmental and social considerations is defined as the ability of the WTE plant to contain its environmental impact attributable to the plant and exist in harmony with the local community. Factors that should be considered from the viewpoint of preventing environmental damages include air quality measures, wastewater treatment, incineration residue measures, noise and vibration measures, and preservation of ecosystem. Main factors to be considered from the perspective of coexistence with local residents are employment of local residents, and local procurement of goods and services. The diagram on the right shows the environmental controls at a WTE plant. Proper equipment and operation are required for the control of all emissions to the outside. Proper combustion control is an important issue in preventing the generation of dioxins. Safety is defined as the ability to prevent or suppress damages to the people or to the facilities, excluding damages to the environment. It is a prerequisite to ensure the safety of neighboring residents and the workers and the equipment involved in the project, by preventing external damages during both the construction and operation phases of the WTE plant. Safety can be generally classified into 1. Disaster prevention, 2. Information security, and 3. Crime prevention. LCC is defined as the sum of the costs over the life cycle of a WTE plant, provided that it satisfies all the requirements of the other 7 components of QWTE I mentioned before. The LCC is roughly divided into the construction cost and the running cost, which includes the waste management cost. The relative ratio of the two varies greatly, depending on the method employed to dispose of the bottom ash and fly ash. In evaluating the LCC from a technical point of view, you should take care that you would not be double counting the influence of this aspect when evaluating the bid price. I would like to emphasize that building a WTE plant inevitably means that you must dispose of the generated ash. The cost burden of ash disposal should not be underestimated. This table is a summary of performance indicators that are recommended for use in evaluating a QWTEI during the feasibility study, planning, and construction phases. Useful indicators to evaluate the initial performance include the number of completed projects, conformity of the delivered plants with the specified performances, and the number of incidents of defective projects, including delayed delivery. Stability may be evaluated by the number of days of uninterrupted plant operation, and the reasons for any outage of long duration. For the evaluation of the ability to smoothly stop and recover, the indicator will be the history of any incidents of long-hour forced outage, before expiry of the guarantee period. The acceptance capability of waste fluctuation will be evaluated by the designed accepted range of waste quality, such as calorific value and minimum consumption rate. For durability, you would want to look at the replacement frequency of main equipment and parts, such as boiler tubes and refractories. The indicator for environmental and social considerations is the monitoring records, and safety should be evaluated based on the number of accidents. WTE facilities embody the fruits of technical development by the companies who have learned many lessons over the years. WTE facilities and technologies not fully proven commercially have the risk of causing some events beyond imagination. We are of the opinion that all data, records, and explanations should be submitted as authorized documents. In some cases, it may be necessary for you to carry out an on-site verification. The LCC is to be evaluated through the bid price analysis. It is also necessary to evaluate the financial soundness of the bidders. This table summarizes the evaluation items for technical proposals. This is just an example, but many project owners evaluate the technical proposals using such score sheets, and giving relative weights to each of the evaluation items. To ensure fair comparison of the bidders, it is desirable to announce the standpoint from which you will be evaluating the proposals. Of prime importance in the evaluation are validity, concreteness, and reliability of the proposal. This table shows the performance indicators of QWTEI with regard to the operation phase. Specific performance indicators are listed for each of the 7 QWTEI components, except for the initial performance. For the operation phase, the ability to maintain and improve plant performance through continual improvement is important, as it affects the LCC, among others. This is a detailed description sheet included in the appendix. This particular one provides details about the performance indicator, accepted range of waste quality, for the QWTEI component, acceptance capability of waste fluctuation. You will in the notes section that concrete numerical values are specified. In this example, the waste calorific value of at least 6 megajoules per kilogram, and the minimum consumption rate of at least 70% are specified. It is very important to specify such metrics for the performance indicators. There are many more such sheets in the appendix. You are invited to make good use of them, setting out your own specifications and requirements that best reflect your individual circumstances. This is an excerpt from an example of the evaluation criteria for prequalification. It is extremely important in a QWTEI project that the required level of technology be secured through the prequalification evaluation. Waste management is a public service that a municipality provides each and every day. Municipal waste management facilities are not testing sites of private company research. I have no more slides to share with you today, but allow me to repeat this to you. Once you do the prequalification evaluation successfully, your chances of having a QWTEI built and running will go up considerably. The WTE handbook I showed you today may be somewhat different from similar guidebooks and manuals that you may have seen or studied elsewhere. Nevertheless, we would be most pleased if you find it of some use for your purposes. This is an excerpt from an example of the evaluation criteria for prequalification. It is extremely important in a QWTEI project that the required level of technology be secured through the prequalification evaluation. Waste management is a public service that a municipality provides each and every day. Municipal waste management facilities are not testing sites of private company research. I have no more slides to share with you today, but allow me to repeat this to you. Once you do the prequalification evaluation successfully, your chances of having a QWTEI built and running will go up considerably. The WTE handbook I showed you today may be somewhat different from similar guidebooks and manuals that you may have seen or studied elsewhere. Nevertheless, we would be most pleased if you find it of some use for your purposes. I conclude my presentation. Thank you for your attention.